Hello, good evening, everyone. Hope I'm audible.
Good evening, Alan. Nakupata.
Okay, thank you. So sorry for being a bit late. Okay, welcome to today's session of Introduction to Linux and Embedded Linux. My name is Alan Koech. I'm a fourth year biomedical engineering student here at Kenyatta University. So today I want to look not into deep Linux, but a bit of an introduction into what is Linux. A bit of we delved a bit into the use of Linux in the embedded systems. It will just be an introductory session. Then maybe in the future sessions we shall combine the Linux plus what we had last week. That was Qt to form a complete package of an embedded system. So what I'm going to cover today, we're going to look at Linux. Basically, what is Linux? Who owns Linux? I know maybe some people don't even know what there's something called Linux in the first place. So yeah, we shall look into that also. Then after that, we shall go a bit deep into Linux. We look at the file structure, what makes up Linux, and what makes Linux what Linux is today. Thereafter, we shall look at the use of Linux in the embedded systems. Basically, here I'll be showing you the importance of Linux in the embedded systems. Where is it used and how basically you can use it in your own embedded system. Then finally, the best part is building your own operating system from the Linux kernel. I'll not go deep into that, but I'll just show you how and tell you the tools to use to have an embedded system made of Linux. So let's start with the first part. What's Linux? You know, most of us are used to uh, Windows, Mac, Android. So I don't think most people don't know about Linux. But actually, Linux is a desktop operating system, not just desktop because it's widely used across platforms, and it has been around since the mid 1990s. So it's an operating system which has been there for long in the market. So something new which is trying to look for a market share because it has been there since and is being used widely currently in the market. So where actually are you finding the Linux operating system? I know most of us are using Android phones, but maybe Android is operating system, but actually it runs on Linux kernel. So most of your Android tablets, Android phones run Linux. I know most of you didn't know that. Yeah, so your Android phone uses Linux, also the Android tablets. Also, most of your thermostats in your cars, refrigerators, the Roku devices, and also televisions, because you all know about the Android TVs, so they run the Linux kernel. So what then is Linux? Because I've been saying Linux operating system. So I said that we all know Windows, we all know iOS for the Mac users, we also know Mac OS. So just like them, Linux is just an operating system. It's a collection of all the tools you need to perform the different tasks on your computer. So Linux has the Linux kernel, which will bundle together with the different softwares you need in your day-to-day activities like the Office, compressing tools, and video like VLC, all those tools. So Linux is just a complete operating system, just like Windows, just like Mac OS, just like iOS, just like Android. So I know for those who are running on Windows, you know that to use Windows, you have to pay some license fee. Also, I think for Mac users, but I've not used Mac, so I'm not sure about that. So unlike those, Linux is zero cost of entry, as in it's free. So you can install Linux on as many computers as you like without paying a cent for software or server licensing. So Linux is free. Basically, you don't need to have a license. You don't need to buy a license to use Linux on your computer. You don't need to buy a license to share Linux to another computer. Because I know I've used Windows before, so to install Windows on a different machine, then you need to have a license on that machine also. So unlike that, Linux you just install on any device you have. No one is going to ask you about the license. Although we also have the enterprise Linux versions whereby you have to pay for the license, but that now is for the big companies who wants to measure maybe in terms of security. You'll have companies like Red Hat, which will give you enterprise Linux operating systems. So also Linux is open source. So if you don't like the Linux operating system you find on the web, on the different companies like Ubuntu, you don't like it, then the code used to create Linux is free and available in the public to view, edit, and for users with the appropriate skills, you can also contribute to. So that means you can download all the code which makes up your operating system. You can edit it, you can change, tweak some few things, make it yours, make it feel like what you want an operating system for you to be. So the only problem with that is that at least you should be having some understanding to some programming, some file system, how Linux works, so that at least you can edit those things, because messing with the core libraries in your operating system will result in very big problems, because you may end up spending some nights struggling with the bootloaders and some other things like that. So basically, just the code for the operating system for Linux is free and you can access it anytime you want it. It's just in the web. So who uses Linux? I know I've told you that your Android phones run on Linux kernel. So apart from that, also the 2/3 of the web pages run on Linux-based servers. Chromebooks, digital storage devices, personal video recorders, cameras, wearables. These are just to name a few, because there's a wide range of devices which run on Linux. It's not limited to what I've just mentioned currently. So Chromebooks are type of laptops which they run, actually is like is a version of Linux which runs on those laptops. It's web based. So I think personal video recorders, you know them, cameras are not just embedded devices. They run actually an operating system inside them to record your tech, to process your images, to store them, to customize them, and all those things. So wearables are things like watches, smartwatches. So all those things, they run an operating system. So Linux is mostly used in such devices. So let's move further. I mentioned that the Linux is open source. So what do I mean by Linux being open source? I know maybe it's a new term for some people. So when we say that Linux is open source, it gives you some freedom. So the freedom to run a program for any purpose. So you can check the Linux operating system, use it for any application you want. No one is going to ask you why you're doing so. You can make an embedded system which is maybe a washing machine for your own. You can make a medical device using the open source code from Linux. You can make any device you want. Like, it's up to you to decide what you want to do with your operating system. Secondly, it gives you the freedom to study how the program works and change it to make it do what you want to make it do what you wish. So apart from allowing you to run the program for any purpose, it will also allow you the freedom to change the code, as I said earlier. You tweak the code, you remove the sections you feel they are not good for you. You add your own code into that, and you run it. So it's up to you to decide how you want it to look like. If you feel like the current operating system is not the kind of operating system you want it to be, then you can tweak it, remove the sections you don't like, add yours, until you're satisfied with it. So Linux being open source gives you that freedom. So also it gives you the freedom to redistribute the copies so that you can help your neighbor. So if I download the Linux image today, I install it in my computer. I have the freedom also to take the same image, install in as many computers as I want. So that's the freedom that the Linux being open source gives it to you. I know with other operating systems like Windows, you'll have also to look for license for each of those devices you're going to install them into. So fourthly, Linux also gives you the freedom to redistribute the copies of your modified versions to others. So if you check the open source code from Linux and you remove some parts, you add your own code, you change it to be an operating system which you find to yourself that is good, something you like. So Linux also grants you the permission to create your own image from that and give it to others without even without having to pay for other different licenses, which actually Linux don't have those licenses. So you can create your own image from the code. You can also distribute it to others by maybe posting in the internet. Others will download it and also install it in their own machines. So Linux being open source grants you those 4 permissions. So next, I know maybe some of you are asking like who actually owns Linux, because we know that with Windows operating system is owned by Microsoft, with Mac OS is owned by Apple company, Android is owned by Google. So by virtue of Linux being open source, so Linux is freely available to anyone. So Linux is not owned by a company. But however, the trademark to the name Linux rests in its creator, Linus Torvalds. He is the man who created the Linux operating system back in the 1990s. The source code for Linux is under copyright by its many individual authors and licensed under the GPL version 2 license. So Linux is a community-based operating system whereby anyone can contribute to the development of the operating system, as long as you have the necessary skills of coding and the like. You can contribute your code into the main Linux operating system. So once you do so, you'll have your own license for your own code. So that's why it says that the source code for the Linux is under copyright by its many individual authors. But most of them are licensed under the GPL version 2 license. So moving on, one good thing about Linux is that it has many flavors. Let me call it flavors, or in Linux we call them distributions or distros. So these different distributions will give you different tests or different feel of the operating system, because they'll come with different themes, different colors from different companies also, because every company will have their own way, like how does the desktop looks like, how does applications open, how does the desktop manager switches the windows. So that will result in many different distributions. You can also create your own distribution and also add into the current list of distributions, because we don't have this limited number of distributions in the Linux world. We have many distributions. These are just to name a few: Linux Mint, Manjaro, Debian, Ubuntu, Antegros, Solus, Fedora, Elementary OS, OpenSUSE. This is just to name a few. This is not the complete list because the list is very long. So you can also create yours today, upload it to the internet, and it will be one of those. It will be one of those operating system desktop distros. So a distro is just basically a collection of particular softwares, like softwares for playing videos, decompressing files. So with a particular desktop manager. So it has been made by maybe an individual or a company which is managing that source code. So it will give you a certain feel. Like if you want to have a theme that looks like Windows, you can get it by using Linux Mint. If you want to have a theme that looks like Mac OS, so you'll have to use something like Elementary OS. So in Linux, you can get all those different look and feel of different operating systems inside Linux. So apart from the desktop distros, you can also have the different distributions for servers. We have both the free servers, because most like Ubuntu servers are free, but also you can also have the enterprise versions of it. Like Red Hat is a company, I think it's currently owned by IBM. It offers enterprise servers and also enterprise security stuff like that. So in the server world also you get a wide variety, unlike the Windows lifestyle whereby you only have the Windows server. So in Linux, you can have a variety of servers. Even you can have your own free server using Linux. No one is going to charge you for creating a server using Linux because it's free for use. So where is Linux currently used? There's no specific answer to exactly where is Linux currently used because it's used across platform. When you go to your, I mentioned earlier, like the Android phones, they run on Linux. That's why you have embedded here. So in the embedded world, you have Android is an example of an embedded Linux. Apart from Android, you have I mentioned other devices like the cameras, video recorders, PDS. So most of them run on an embedded operating systems, which is mostly embedded Linux. So apart from the embedded world, you also have the servers. So Red Hat is an example of an enterprise server, although you can also use Ubuntu and all the other distros. Most of them offer both the desktop operating system as well as the servers. In addition to that, also you also have the normal desktop operating system, which will just operate like the normal Windows, like the normal Mac OS. You can run your day-to-day document readers, PDF readers. You can type your normal office work, install different applications, watch movies with it. So just a normal desktop operating system. So Linux by itself will offer all those, both the desktop, embedded, and also the server. So maybe a small comparison chart between the three, Linux, Windows, and Mac. I know these are not the only operating systems currently in the market because there are many other operating systems, but these are the three major. So when we talk about free for use, of course, Linux is open source, so it's free for use. I think for Windows and Mac, you have to pay some license fee. So also Linux, I'd say it has a lot of distros, so that means you have a lot of choice of how you want your operating system to look like. So for Windows, I think, and for Windows and Mac, I think for each version, it will have a specific look and feel. Customizability, I think Linux is very customizable because if you don't like maybe the desktop environment, it comes with a particular distro of Linux, you can remove that desktop environment, you change it. If you don't like maybe the kernel, you can remove that kernel, you change the kernel as long as it's compatible. If that's the issue, maybe if it's not compatible, you can decide to build your own, compile your own operating system from the source by downloading the code. You tweak the code and compile it. And like for Windows and Mac, you can't find their source code because it's owned by, for Windows, it's owned by Microsoft company, and they haven't made their source code public. Also for Mac is the same. It's proprietary, so you can't customize your operating system beyond some point. That's a limitation. Maybe you just change the desktop theme, the color, the font, just to name a few. But for Linux, you can change almost everything in the operating system. In terms of flexibility, Linux is very flexible. You can install Linux in a server. You can install Linux in a hardware which has maybe 10 GB of RAM, as well as small as 100 kilobytes of RAM, because you can have very small operating systems from Linux for the embedded use, as small as 20 MB, 10 MB. Unlike Windows, which I know is almost 4 GB, 5 GB, a normal ISO image. For Linux, you can have even as small as 4 MB, which does a specific purpose. So that's for the embedded world. But for normal desktop Linux operating system, for normal desktop versions, they range from around 100 MB, 500 MB to 1 GB, 2 GB, 3 GB. So this is not the complete list for comparison. At least there are many other things that brings the difference between Linux, Windows, Mac. So let's go a bit into Linux. I know I've told you what's Linux, where is it used? No. So let's look at actually what makes Linux, because Linux is a bit different from Windows, a bit different from Mac. So what makes Linux what Linux is today? So a normal operating system will have 3 layers. First is the hardware layer. Then you have the operating system, which lies on top of the hardware. Then you have now the user space, which is because the end user, where you'll be installing your own applications. So the hardware basically will have the CPU, memory, hard drive, RAM, all those peripherals. So it will make up the hardware layer for your computer or your device. Then the operating system is what now will be installed on top of the hardware. So operating system now will be things like Windows, Apple, Mac OS, Linux, Android, and many others. So the operating system now will be a bridge between the hardware and also the user. So the user space will now come in terms of the applications you want to use. You now install on top of the operating system. So have you ever even asked yourself, like, do you really need an operating system once you boot your computer or your phone or your tablet? Do you really need an operating system? Because that's a question someone once asked me. So how does your processor in your computer know that you're asking it to run maybe an MP3 file or even open a document, save a document? How does the computer know? Or how does your microprocessor know in your computer? So basically, that's the work of the operating system. It's the bridge between the user and the hardware. So the work of your computer, as in, so to work on your computer, you need an operating system. Whether it's an embedded system, although in some embedded system you go bare metal because maybe you'll be using something like a real-time operating system, RTOS, or maybe just pure code on the bare metal. So, but most of the devices will be running on an operating system. So even now, currently, as you are speaking, maybe as you're watching this webinar, you're using an operating system, maybe an Android, maybe an iOS, Mac OS, and many others. So you need an operating system between you, the user, and the computer. So basically, the operating system will do most of the heavy lifting. You ask it to play the MP3 file, it will now figure out where this folder is, how to play it. It knows how to play the file and how to communicate with the hardware, maybe the speakers, maybe the headphone, and the like. So basically, you need an operating system in your computer. You can't stay without it. So let's go deeper into the Linux operating system. So Linux is made up of some parts which are very important. So the first one is the bootloader. You have the kernel, you have the init system, daemons or the services, you have the graphical server, and finally the desktop environment. So the bootloader is a software that manages the boot process of your computer. So most of the time when you're booting on your computer, you'll just see a splash screen, maybe a small logo, and then it disappears. So this basically is the bootloader. It manages the boot process. It takes over from the once you boot on your desktop, it will take over from the BIOS or the UEFI. When it comes to the bootloader, the bootloader now will take off from there and call the next process, which is called the kernel. So kernel is the core of the system and manages the CPU, memory, and peripheral devices. So kernel is just the basic lowest level of the OS. It knows how the hardware is. So once you start the bootloader, you power on maybe your computer. It goes through a BIOS or a UEFI. Then that one now will now identify the bootloader on the hard disk or on the SSD. Then the bootloader now will initialize the kernel. Kernel now will prepare all those hardware, find out where is the hard disk, where does it start, in what sector does it start, all those stuff. It will be done by the kernel. Oh, so sorry. So once the kernel is now done, it will call the init system. So init system is basically, it manages the boot process. Once the initial booting from the bootloader, it manages the boot process once the initial booting is handed over from the bootloader. So maybe for the Linux users, the bootloader is mostly the grub or the grub2 or the grand unified bootloader in full. So once the bootloader has finished its process, it will initialize the init system also. So the kernel, then the init system. Init system will manage all the boot process. So apart from the init system, we also have the daemons, or another name we call it the background services or the services in Windows. So background services, example are the printing, sound, scheduling, etc. that either start up during boot or after you log into your desktop. So basically, the background services will be running the important services like setting up your network, ensuring that sound your things do like printing, sound, it will be handled by the services in the background. Apart from daemons, you also have the graphical servers. So basically, the graphical server is the one that now manages how things are being displayed on your screen. You have a very nice UI on your screen. You can switch windows, and everything will be displayed very well. So that's for the Linux part, it will be handled by something called X server, or there are many servers. So it's basically the subsystem that displays the graphics on your monitor. It's commonly referred to as the X server or just the X. Although there are many other servers you can use, it's not a must to be running on the X server. So apart from the graphical server, you also have the desktop environments and applications. So the desktop environments and is basically, and the application is what actually most users actually interact with. Like for example, you have the GNOME, Cinnamon, Mint, Pantheon, and the likes. So these are just what the desktop environments. They'll now determine like how does your files look like how does your desktop environment look like, how are the different windows stacked on each other, how are they arranged on the desktop, because normally you know that you can have multiple windows running, and all of them, once you click on them, they're brought onto the view, and it doesn't either load, so it's being handled by the desktop manager. So each desktop environment includes built-in applications such as the file managers, configuration tools, web browsers, and also games. So applications, basically this part of application is handles the user side, whereby you can install your own applications, you can play games, you can do many things as you like. You also watch movies, go into a browser, emails. So these are the application part. And all those applications you open, and they'll be handled by the desktop environment or the desktop managers. So moving on, unlike Windows, how folders are structured in the hard disk is a bit different in Linux, because in Windows most of the time you have the C directory, and if you have another folder, you'll have the D directory, E, F, G, and so on. So, but in Linux you only have one root directory, which is usually shown by a /. Then inside the root directory you have a lot of folders. So the root directory inside the root, this is the root. Then now we have a folder called the root. So root usually is a home directory for the root user. In Linux, we have the root user and you have a normal user. A root user has the authority to execute most of the things. Like there's some things you need permissions, so the root user can execute all of them. But for a normal user, you need to maybe to have a password, input your password, or you cannot even execute some commands. But the root user will have a folder called root, whereby it will be storing all the configuration files for a root user and the likes. The home folder is basically, it will store the configuration files and the settings themes for the current user who is logged into a computer. Like if maybe your name is Joe or your name is I don't know who, so you'll have a folder called home stroke your name, your username which you're using in your computer. So inside that folder now you'll have all those configuration files, your settings for maybe the desktop, the themes you have chosen. They'll be stored inside a home directory. A boot directory will store most of the time the static boot files. Like this is where now the bootloaders are located. So this is the folder most of the time in Linux you're told do not mess with it, because if you just mess something inside there, then your application is not going to boot. The sbin and the bin. So bin in full is just the binaries. So in the bin directory, you'll be storing the binaries for the normal user, whereas in the sbin you'll be storing binaries for the system. You'll be storing the system binaries. By binaries, I mean like if you have an application, then there's an executable whereby if you double click on that, it will run that application. So that's a binary, because that's been compiled into a binary. So that binary is stored in either the binary, into the bin folder if it's for a normal user. But if it's important, then therefore it's a system binary, it will be stored inside the sbin folder. So the user directory, this will contain all the user programs. So if you install something like maybe a browser like Chrome, Firefox, it will be stored inside the user, maybe local directory inside the user directory. Although also the user directory will have the bin folder for storing the binaries. So the user directory will just store all the system, the user applications. The var, just in full is called the variable. So the var will just be storing the variable files in the system. Dev will be storing the for the dev, it will be storing the device files. Like now, unlike Windows, if you create a new directory in Windows, then it will be maybe a D directory or an E directory. But in Linux, you only have one root directory, which is this one up here. So if you create a new partition inside the hard disk or something like that, or you mount a new device, if you create a new partition, it will be inside the dev. It will be dev slash, it will be slash dev slash SDA something, or SDB, because all those partitions you are creating will be under the dev directory. So the etc just be storing things like configuration files. Like now for the boot part, you have the bootloaders, but now these bootloaders need a configuration files. These files will be storing settings, some settings to the bootloader, like how to boot, what to show during boot, which picture to show, how long should it stay on the boot section. So all those are stored inside a configuration file, and that configuration file is stored inside the etc directory. So for the opt directory, this directory will be storing things like optional add-on apps. Like usually Linux has a format for all its application. Like for a browser like Firefox, you'll have the binary file and other library files. So if your application does not follow that procedure, then it will be saved inside the opt directory. Yes, it will be running, yes, but inside the opt directory. Also, most of the enterprise softwares, they also be stored inside the opt directory. So the media directory is just where you mount, like this. When you put in your maybe a CD drive into your computer, it will be mounted into a media directory. So this is basically just an overview of how a basic Linux operating system will have its directory structure. Maybe in others you also have folders like the lib folder. Basically, the lib folder will be storing the library files, and these library files are just the library files needed by the binaries in the bin folders. Because once you start the bin folder, the bin applications, then they need the library files. Maybe they are dynamically linked. So all these libraries will be stored inside the lib folder. So moving on, let's now, that's just an overview of how Linux looks like. Now let's look at Linux for embedded use. In this section, I was not planning to teach how to install Linux on your machine, no. So I want us to look just into an overview of all those sections: Linux for desktop, Linux for embedded. So now, for the next two sections, I'll be dealing with the Linux for embedded systems. So I know all these things I've been mentioning them in the previous section. So this is the core of an embedded system, a Linux embedded system. So just like a normal Linux operating system, which is running maybe on a server or a desktop, it will still have the bootloader, kernel, root file system, and services. This is what it should have in an embedded system. Because in an embedded system, the operating system will not have all those functionality. Some of the functionality will have been stripped off, because you might not need all those functionalities inside an embedded system, because maybe you want it to perform a specific task. So the first important thing which should be there is a bootloader. So its main job is just to find the operating system, operating system's binary program, load that binary into memory, and run the operating system. So mostly in the embedded world, we are using something called U-boot. Unlike normal desktop applications, normal desktops, you'll first, when you boot application, it goes into BIOS first. Then now BIOS will now start the bootloader. But in embedded systems, you don't have the BIOS. When you just start your application, when you start your machine, it goes into the bootloader directly. So then after that, you have the kernel also. This kernel will it will run the startup code. This startup code will initialize the hardware, initialize the system critical data structures, initialize the scheduler, initialize all the hardware drivers, initialize the file system drivers, mount the file system, and also launch the first program, among other things. So once the kernel just like loading all the drivers you have in your system, it will be handled by the kernel for all the sound and like sound, file system, ports, all those things will be handled by the kernel. Then you also have the root file system. For the root file system, I'd shown you how the file system looks like here. So basically, this is the root file system which is supposed to be. This is how it should be also in an embedded system. You'll also be having the boot directory, the home, the binary, sbin, user, because all these directories have their purpose. They'll be storing some data or data information or even files which are required by other processes. Apart from the root file system, you also have the services. Services in Linux, we also call them daemons. So the init program will launch all the necessary services and applications that are needed for the system to be useful. This set of services include setting up network, mounting additional file system, setting up a graphical environment, and more. So I think these are the 4 important things that in any embedded Linux operating system, you will have them. You'll have all the 4: bootloader, kernel, root file system, and services. You can have some others apart from these ones, depending on how the application needs. Your application might be having extra modules which now need to be incorporated into the operating system. So these are the basic ones which should be there for any embedded system, Linux embedded system. So basically, when you start your machine, it will jump into a bootloader. Then after the bootloader will now initialize the kernel. Kernel will mount the root file system. Then now the init is started, whereby it will start all those drivers and like. Then after that, now it will load and run run background services or demos. Then after that, now you come to your application. Like, for example, you have an embedded system whereby let me just say, maybe you have a medical device, which once you put it on, in some 2-3 seconds, you should be seeing the graphical user interface, the interface between the user and the machine, that UI. So basically, it will have to go through all these processes in that short time, because it's dedicated for that purpose. Unlike a desktop environment whereby it will have to boot, ask you for a username, ask for a password, then load a bit, then open the desktop. From the desktop now, you'll have to choose the particular application you want to start. But in an embedded system now, the application to be started is predetermined. So always when you boot the application, it boots directly into a particular application inside the file system. So moving on, there are a variety of hardware you can use for the embedded Linux. This is not the full list. You can have many other. Also, you can also make your own, as long as just you make your own, then now customize Linux to that hardware. So the first one, this one is a Raspberry. It's a Raspberry 3B. Although for Linux embedded, you can use from Raspberry 0, Raspberry 3A plus, 3B, even 4. So the second one is a Big One Black. It has a 1 gigahertz, 512 MB RAM. For the Raspberry 3B plus has a 1 GB RAM, but for Raspberry 0 it has a 512 MB of RAM. You also have a Pine 64 Rock board and Latte Panda. For Latte Panda, this is a big machine. You can even install Windows inside it. So all these boards or you can install, you can use them for an embedded Linux application whereby it will be running your operating system and doing all the activities you want to achieve with your embedded system. So this is not a complete list of all the hardware. You can also design yours using any microcontroller or microprocessor, and then you take the source code for Linux and make it exactly to suit your needs. So how different is the embedded Linux from the normal desktop Linux? So embedded system boots from the flash instead from hard drives and support flash file systems. Usually, you know that from a normal desktop computer, you'll be having a hard disk whereby your operating system will be stored inside the hard disk. But for an embedded system, you'll have mostly a flash electrically erasable memory inside on the board. So your operating system will be stored inside that memory. Secondly, the embedded system don't support BIOS unlike PC. I told you earlier that once you start a desktop computer, to start the BIOS or the BIOS. Now the BIOS will now instantiate the bootloader for your operating system. But in embedded system, you don't have BIOS. Thirdly, embedded systems are resource constrained. Harness can't run bulky OS. In most embedded system, you'll find that all these resources are constrained. Like you might be running in something like 100 kilobytes of RAM. A normal Windows operating system will be told that minimum requirements around 2 GB of RAM or 4 GB of RAM. So you can't run such a big operating system inside and such a device because it won't run at all because the resources in such an embedded system may not satisfy the requirements for that operating system. So also embedded systems are battery operated and low power devices in general. You find like mostly like, for example, your wristwatch is an embedded system. It can stay even for 3 days without being recharged, or even a whole week, or even a whole month. Unlike a normal laptop whereby you'll have to charge maybe after 5 hours, 6 hours, 4 hours. So embedded systems, they run on low power. They're low power operated. Also, embedded system may be based on different processors and support different peripherals based on customer requirements, and hence the hardware is not generic like desktop PCs. You all know that if you're running a computer, maybe Windows, you know that your processor is either an Intel or AMD or NVIDIA, something like that. But for embedded systems, you don't have a specific hardware that this hardware is for embedded systems because you can design your own hardware the way you want it, as long as it performs the tasks you want it to perform, then it's an embedded system. So lastly, embedded systems require real-time performance. Like for example, for a medical device, you can't have latency, you can't have something that loads for long because maybe someone's life it's at stake under such situation. So you require real-time performance. That's why most embedded systems have specific roles, specific function they do. They'll boot up maybe to a specific UI and only that UI, nothing else. So we have looked at the embedded parts of Linux. So maybe the last part I want to touch on is customizing your Linux to a specific need. Maybe you want to come up maybe with an embedded system whereby maybe like a dishwasher. You want to have a system whereby it can control it can handle all those inputs from the user, changing the water temperature. So you can't use a normal Linux distribution like Ubuntu. You can't install Ubuntu inside there because it's too big for that purpose. So for an embedded system, then you'll require to at least change some things in the operating system. So back in high school or maybe in university or back in college, primary, remember your chemistry classes whereby you are told to maybe make something maybe like sodium chloride. You are told to mix maybe 1 gram of sodium with HCl and maybe you get sodium chloride and something else. So that what you are doing there, you actually trying to get something else by using different materials. So also in embedded Linux, you'll be able to have such a similar approach whereby you'll be taking small portions from different parts, bringing them together, removing some sections from what you have already. You delete some sections, you add some other things, then you compile it. You have your own operating system. So, like for example, you choose a particular kernel. A kernel, I told you the function of a kernel. And then maybe for your embedded system, maybe you have a Bluetooth receiver. So maybe you also have Wi-Fi sound. Depending on what you have, you'll have to add the additional drivers for that into the system. Maybe now for an embedded system, you want to run a particular application, like you have a UI which maybe controls the temperature in a room, something like that. So you'll have to have a particular user interface for that. Apart from that, maybe you want to have other things added into the system. So you will have to take all those things, bring them together, put them into a nice package, compile it, then you'll have your operating system, which now you can boot into your hardware. So unlike the chemistry classes whereby you are using pipettes, maybe all those things, I don't remember all those things. So when you're building now for Linux operating system, you have, these are the two major things we use. The first one is called Yocto project, and the second one is called Buildroot. So these two will enable you to pick what you want. Like I want to have a Wi-Fi module. I'll be having a Wi-Fi module inside my embedded system. So I want a Wi-Fi driver for that. So you add it into there. You also want, maybe you want to play, you'll be having a sound card or a speaker. So you want to incorporate all those audio drivers inside your embedded system. So these are two powerful tools, although these are not the only ones. So the first one is called the Yocto project. So this provides templates, tools, and methods to help you create a custom Linux-based system for embedded products, regardless of the hardware architecture. It's a collection of recipes, configuration values, and dependencies used to create a custom Linux runtime image tailored for your specific needs. So when you're talking about recipes and configuration values, this one now will be telling the system that builds now everything, that add this, remove this, add this, remove this. When you talk about Buildroot also, the Buildroot also is a project, is a simple, efficient, and easy to use tool to generate an embedded Linux system through cross-compilation. So it shares many of the same objectives as Yocto projects mentioned above. However, it's focused on simplicity and minimalism. So both of these two tools will give you, will enable you to generate an operating system for an embedded use. So although they're not the only ones, you can also take a normal Linux distribution and customize it. Let's say you don't want the desktop environment, you remove it. Although that's not the most effective, because it will still be bulky. But these two tools, Yocto project and Buildroot, they're the most powerful ones, because for most of the embedded Linux operating systems, they'll be made using these two. So why build your own Linux operating system? Why not just use Windows? Why not just use something else? So Linux gives you some advantages. The first one is compatibility. Second is license. Third is security. Fourth is stability and reliability. And fifth is flexibility. When we talk about compatibility, we say that Linux embedded systems operates on pretty much all hardware, on all hardware platforms, processors, routers, etc. So it can be adjusted to meet the specific needs by the user. In terms of license, I told you that Linux is open source, so you can deploy your custom operating system to as many devices as you can to as many devices as you can feel, and it's free of charge. No one is going to charge you for deploying all those things in different devices. In terms of security, Linux offers you account privileges, whereby to change some files or delete files in the root file system, then you need to have the root password, because it will prevent things like corruption of data and something like that. In terms of stability and reliability, Linux operating system can be running for years without failure, because we all know that it powers almost 2/3 of the internet, so of the web server. So you can't be having every time it goes off, you lose your internet because you can't access some sites because the servers have gone off, they're rebooting. So Linux will offer you the stability and reliability. Like you might, like for example, you might have a medical equipment. So in the middle of an operation, maybe it's a medical device which it helps during operation. So you don't want such a system to be rebooting or auto updating itself, and like so, because it will cause missing dependencies in the system, and it will end up in corruption. Also, the system will just crash. So in such critical places, you don't need your system to be auto updating and something like that. It should be reliable and stable. Also, Linux is flexible. It's just like compatibility. You can install it in any device you want. So, just a simple example. You want to have a system, maybe you want to have maybe a medical device, for example, maybe a ventilator. So there's a process now maybe you have to follow so that you can get such an operating system. So first you'll have to build your own custom OS, because once you know the hardware, then you can build an operating system for that, specifically that hardware only. So once you have that operating system, then now depending on the hardware, like maybe you have a Bluetooth driver and the likes, then you'll have to add all those services to it using different scripts. You'll have to write some scripts to initialize all those devices, like set up the Wi-Fi, set up the network and the likes. Then once you have the two, you have the operating system and you have set up all the scripts for the different services which will be running in the background. Then now you will have to have ready your user interface, your human machine interface. So maybe you have made your user interface maybe using Qt or any other user interface language you like. Then now you bring the user interface, you merge it into your operating system, into your operating system image. Then now once you have the three together, you can just deploy them into your hardware, your target hardware. Your target hardware can be a Raspberry Pi, it can be a Big On Bone Black, or your custom hardware. You'll just merge them together and boot, and you'll have a machine whereby you start your machine in just a second or two. You're already in the human machine interface. So that's how an embedded system should basically be made, actually. So in summary, in terms of hardware, I'd say that Linux is very flexible. It can run on many different chips like ARM, PowerPC, MIPS, etc. So most of the custom operating systems for Linux are usually very small. Actually as small as 4 MB, 10 MB, 21 MB, 30 MB, depending on what are the processes and the background services you'll be having inside your operating system. Because if you want to be accessing the internet, you want to access Bluetooth, you want to access all those different things, then it will be adding some code and you'll be adding different codes and different scripts into your image. So it will be increasing the size of your image. In terms of customizability, this is the best part about Linux, because I said you can customize it the way you want. If you don't like part A, remove part A. If you like something else in a different distribution and you want it inside your current distribution, you just install it inside there and remove the one you have, and you can get a Linux version which is the way you want it to be like. You will have it like because I know everyone has their own likes and dislikes, so you will have it exactly the way you want it to be. So in terms of real-world applications, I'd mentioned this is used everywhere, like in smartphone, tablets, routers, robotics, even in your security cameras. They usually run a full operating system inside them. So I think I don't have much to add on this today. So if you have any question on this section, it's just been exactly 1 hour. So you can ask any question. The floor is open. Just unmute your mic and just ask any question.
Alan.
Yes, yes.
Okay, I have a question. My question is,
Uh-huh.
like for instance, when you look at Windows,
Mm-hmm.
every time, let's say, like there's a new version, like we usually get updates for Windows. Like so, like I was wondering,
Mm-hmm.
so when it comes to Windows, because now it is open source, do they also like also update? How do they update? Do they also update like Windows?
Oh, no, actually, it's Linux, not Windows. So in Linux, we have the security patches like PATCHES. Like the Linux, I said that Linux is mostly driven by the community. So you find that every month or even every week there's an update. But unlike Windows, you do not be automatically updated. You'll have to select the update and see if you want to install it or not. So you'll also have to have the root password because you'll have to authorize the update. So Linux also has all those updates because for the different distributions like the Ubuntu, Manjaro, Debian, they're run by some companies somewhere. So those companies ensure that these things are up to date. And also the Linux kernel is updated regularly. That's why you have different versions of the Linux kernel. So yes, in terms of updates, yes, Linux is open source and has all the updates. Yeah. Hope I've answered your question.
Yeah, you have answered. I also have another question. Huh?
Yes. Yeah.
The other question is, let's say, for example, the kernel now you are talking about.
Uh-huh.
Let's say now, like, let's say, I want to go to the back end. Let's say to change the code. Like, how do you do that?
Or you want to change the code for the kernel?
Yeah.
Okay, I told you Linux is open source. So if you just go into the internet, you'll find the full source code for both the operating system as well as the Linux kernel itself. That code is open source, like it's Ikoko Web. So if you want to change something in that code, in that kernel, you just download the code yourself. You change the particular sections you want to change and compile it, and then you can install inside your system. Yeah.
Oh, okay. Yeah.
Yeah.
Thank you.
So. So any other question? Okay. If you have any questions, then you can reach me through these sections: LinkedIn, email, mobile number. Also, if you want today's presentation, you can just text me, or you can just send me a message in any of these platforms, and I'll send you today's presentation. Also, if you need any kind of clarification, you can also ask me through these platforms. So I think for today, that will be enough for today. So just an introductory phase. Then maybe in the successive sessions, we can go deep into some of these things, because it will require you now to at least have understand. By now, I think you know something about Linux, so you can go read about Linux, maybe install Linux, play with Linux a bit. You see how nice it is. So last week we looked at Qt. Qt is for designing the user interfaces and many other things. So in the next session, we shall make a very nice UI for using Qt, and also we shall deploy into an embedded Linux. For our case, we're not going to compile our own OS. We're just going to use the normal Raspberry OS. So we shall make the UI, deploy it into Raspberry OS, and I think that will be enough for the next session. Then from that, now we can see on what to do next. So thank you all for joining me today in this webinar.
Last question.
Okay, yes.
Last question. Sorry to cut you short. Oh, I wanted also to ask or to know.
Uh-huh.
Right now I'm using Windows. Let's say now I also like want to install Linux as well. So
Yes.
where can I download it from? Like, can I also run the two side by side?
Yeah, actually, you can do what you call dual booting. Like you have both Windows and Linux installed inside your same hard drive. So they'll be in different partitions, so that when you boot your machine, you will choose like, do you want to boot into Linux or do you want to boot into Windows? So it's called dual booting. So you just, when you want to use Linux, you boot into Linux. You want to use Windows, you boot into Windows. An alternative to that is that if you have enough RAM and you have a fast processor, you can use a virtual machine inside your Windows. You can run a virtual machine inside the Windows, install Linux inside it. But I'll advise you to use dual booting, because with that you can have the full functionality of a Linux operating system. Yeah.
Asante sana.
So thank you everyone for joining me today. I think you can also meet next week for the next session. Thank you so much. Have a blessed evening.
Thank you too. Have a blessed evening too.
Thank you.
Arigato.
Thank you, Alan.
Welcome.
Thank you.